Welcome back to track 4. Our next talk will be Home Defense for an Internet of Things Infested World, presented by Dale Lakes.
Test. All right. Good afternoon, everyone. Hope you all had a good lunch. I know typically after Chick-fil-A, I want to just immediately take a nap, so I'll try to not be boring. Talk today, talking about is Home Defense in an IoT Infested World. Just a quick background on me. Recently graduated college, 2017, computer science. Played Capture the Flag a lot. So most of the things that I've learned was through Capture the Flag. If you have the chance to play in a Capture the Flag competition, and you've not before, I highly recommend it. They're a lot of fun. Started my own security company in Augusta. Been doing that for about 6 months now. It's our first conference that we're sponsoring. And my big thing is Go. So anybody that knows me knows that I love the Go programming language. So I'll be pushing that a little bit today, but more of the focus is going to be on the way that we approach network security for your house. So what am I talking about today? Talking about a new machine learning approach to big data analytics by correlating cloud-native threat intelligence to real-time cyber threat feeds and feeding those models into a neural network endpoint protection platform in order to generate threat graphs on the blockchain with just a Raspberry Pi Zero. All right, if anybody needs to go to the bathroom because they just could not take all of that buzzword jargon awfulness, I don't blame you. All right, what am I actually talking about? So as a homeowner, as anybody who cares about home network defense, there's a lot going on, and you're just one person. Man of the house, woman of the house, whatever, it's your responsibility to know what's going on in your network to defend your family. So I'm going to be trying to take a very straightforward approach to this problem, so that you don't have to spend a bunch of hours learning some, crazy new technology or doing something that requires a lot of, time that you don't have. Next, I'll be demoing a new project that I've been working on that goes along with this, and then, in general, talking about the fight against snake oil. So when I say snake oil, the definition that I'm going to be using is what's in red, the cure-all elixirs. This idea that if I just run this magic tool, it's going to solve all my problems. I give it my packets, it spits out the bad guy. That's really not how anything works, if anybody has been in this field for more than a minute. There's a lot of talk about using these buzzwords like cyber, AI, machine learning. Your home network is very unique. The devices that you buy and the things that you do on your home network are not like anywhere else. Enterprise networks generally have a process or a standards that they follow. You, with your home network, do your own thing because you get to do whatever you want. And so if we try to approach this problem the way that traditionally, you would maybe go to some government website and look and see how they recommend to defend your network. And here's just a quick description from DHS and DoD-CIO of how to defend your home network. Most people who have been in this community for a while know these things. There's nothing surprising up here on the slides. So when you go to the conference and you learn about these things, you're like, okay, cool, and you do them pretty well, and you're happy about what's going on. But then let's just say, let's pretend that I'm some 30-year-old family man. I got a couple kids, and Christmas is around the corner. I also just moved. I moved from down here in Georgia, let's say, up to Maryland. And so I get to this new apartment complex, and they have this smart lock. And this smart lock, you can use your phone to remotely unlock your house. You also, your kids really want for Christmas this Wi-Fi connected camera because they can share. Your two little daughters can share pictures with each other, with their family tablet. And then they want the smart speaker. One wants the bear, one wants the duck, so that they can be in the room and listen to their favorite music. And then, of course, your wife wants the all-powerful internet-connected toaster because why not? Just add fuel to the fire. And so what do I do about all this garbage that has now just been introduced into my home? I can't just, tell my wife and kids your needs are not valued here. You can't have these things. Maybe you can. Probably should. I wouldn't blame you if you did. But, let's just assume, for the sake of the argument, that you let these things into your house, or especially for the remotely connected smart lock, like you have no control over that if you live in an apartment complex and they you walk into that situation. It's a pretty hard process to get that changed. So let's just assume that you have all these things. But first, let's take a step back. Why should we even care about these IoT devices? I'm not using them for anything that's sensitive or private. It's just there, letting my kids take pictures, letting me unlock my house. Nothing crazy. But do you remember this guy? This camera thing? It's from Amazon. I pulled it off Amazon, bought it, did a little bit of research into it. Like a lot of IoT talks tell you about how terrible and awful they are, and I'm not going to go down that rabbit hole because there's enough of those. I'm just going to do a very brief overview of just one example of why IoT matters from a security perspective. So this device is a Wi-Fi connected kids camera. You download an Android app to communicate with that camera. And then the app itself, when you download it, comes with a C++ library as a shared object. Has over 1 million downloads, created in Taiwan by some company. And when we tear it apart, you look and see, and you can be like him in the bottom right and start losing your mind a little bit. The app allows you to basically specify whatever IP address you want to send these streaming pictures of your kids back to. All these permissions on the top have, let me access all your Wi-Fi and change the state whenever I want. Let me have a wake lock turned on so that I can always be running. Let me modify your audio settings, write to external storage, basically do all the things that any sketchy app would do. They also implemented all these custom commands where they can download, upload firmware, send raw data to the firmware if they want. Who knows if that's secure? Probably not. Doubt it. And so you can decide to go down that rabbit hole, and you can start messing with IoT devices and getting freaked out more and more, and eventually you'll turn into, I forget his name, Sunny in Philadelphia guy, bottom right. Carly, yeah. All right. And so even if you did want to control this device and have greater control over what these devices are doing, you don't have a user interface to actually interact with. Like you just click a button and it takes photos. There's no source code. You have to pull the firmware yourself. There's a lot of hardware that exists on there to send and receive data that you also have no control over. They're always on. They're always running. And it's in your house recording your kids. So what's wrong with that? So you decide, as the family man or family woman of the house, that you're going to set up a home network security architecture. You've been to, Security Onion Con. You've been to all these great different things, and you've seen all these great, sexy tools. Let's just use all of them because, they all must do something important. And so you begin the descent down the rabbit hole of creating your home network security architecture. And so first you start with Wireshark, and you start looking at the packets coming across. You're like, oh, that's cool. I didn't know that thing was talking to that thing. I didn't know that even talked to the internet. I didn't even know that thing had wireless capabilities. And so you start looking and seeing some weird stuff. But then there's a lot of data, and you just can't handle all that. So naturally, the next thing is to build a dashboard. And that dashboard gives you great summary statistics about everything that's going on, who's talking to what, where, and when, at what frequencies. Maybe you start learning some query languages. You're learning the Splunk query language or the Elastic query language, so you can get more fine-grained control over what's going on and start having a greater understanding of your network. And then you synthesize all that up in some other cool tools, and you got some automated notifications or custom alerts, and you've done a lot so far. And you start looking at bro logs, lots of bro logs, so many bro logs, summaries of your bro logs, the payloads of your bro logs. And it just never ends. There's just always so many things to look at and so many things to do, and you're always just scrolling and scrolling and creating new dashboards. And eventually you just completely burn out because you have no way. You have no idea why you did all these things. You've just been lost in these tools because these tools are going to solve all your problems. And so this common thing is alert fatigue, right? You're just getting inundated with a bunch of different alerts and notifications and dashboards and spikes and whatever thing says, maybe there's a bad guy here, you should look at this. It's just unbearable as somebody who's trying to defend their network, or their home network especially, because you're just one person. And there's a lot going on. And as IoT continues to come into the house and as various different devices start connecting to the internet, there's only going to be more and more and more data that's going to be coming across your network. And so what are you supposed to do? Like, there's so much data. There's really no way you can do it without tools. You can't just pipe stuff to, pipe all your data to some log file and then use grep. You can't just, you have to use some sort of visualization or some tool. And so you have two choices. You have two choices with this. One, you go all in and start finding some more magical cyber, right? Or maybe you find something that has machine learning and AI because it's going to make the malware cry. It has to be there. You haven't found it yet, but it just has to be there. There's no way it's not there. And so that's one approach. Or the other is you recover. You start actually taking an introspection into why you did all this in the first place and understand what is the point of actually doing all this stuff. What am I actually trying to defend as a homeowner? And so I have two things to give away. I will let the person who can answer this question correctly pick whichever one they want. It looks like a wireless adapter, AC1200, from Alpha Network, and the other one, I believe, is a lock-picking kit. I don't know, something in a zippered bag. So, who can name the person in the picture? Correct. So that is one of our presidents, in case you didn't know. Yes. Did you want this one, or do you want that one?
I think I'll do the lock-picking.
All right, cool. Yep.
Let the
All right. So Warren G. Harding's famous for the return to normalcy quote, so I included him. All right, so now you're in recovery. You've decided to not go down the AI machine learning, going to get your PhD just so you can defend your house approach, and decided instead to take a step back and say, okay, what do I actually care about? All these things are automated. What am I actually, why does this tool suggest or imply that it will magically find malicious traffic for me when it has no idea what's actually on my network? It's not designed for my network. It's designed for enterprise. What is the false positive and false negative rates for any of these things? And is their definition of weird or abnormal in line with my definition? Is this IoT device, was it made weird to begin with? Do I actually need to classify everything that it's doing as weird, or can I just say, okay, that's normal, and move on? And so we bring it back to the basics, right? Network security, we care about privacy, confidentiality, integrity, and we want to make sure that the decisions we make are based on accurate data, and that we are not getting, things aren't looking at our traffic or looking at us. If IoT, you got your cameras and audio and all that stuff. You want to make sure that your privacy is protected and your family's privacy is protected. So the initial approach. Here's some good questions to ask, right? Where and how does my family use data to make decisions while at home? If they are looking at, a smart speaker, what are the results that smart speaker is giving to them? Is that, has it been locked down so that my kids are receiving and making queries and getting data back that is in compliance with maybe my home or network usage policies, or just, good practice? So, for example, next slide I have, is my child using their iPad after their bedtime? Are they, watching Netflix after their bedtime? If you got an SSH server that lets you get back into your house, are you using fail-to-ban? Is it actually still working? Or are you just blindly hoping that it's working and not actually monitoring that? And then what are your IoT devices talking to? If you set up a VLAN, is the VLAN actually working? And, are your home security devices functioning properly while you're not at home? So I should be able to, if I have a IoT connected camera, be able to quickly verify that that camera is running, not just because it gives me a screenshot, but because I actually see the network traffic of it running. Because some adversary can just keep giving me the same screenshot. We've all seen it in the movies, right? Like, you can do that. It's pretty easy if you're able to hack the IoT device and have it broadcast, just the same picture over and over. So stuff like that. Those are some good questions to ask, and that's where you get started. Not just turn on all the data and just influx all of my tools. And so what we discover, at least initially, is that you still have to gather all the data at some point, unfortunately, and store it somewhere. Because there's really no good way for me to filter out the data at the beginning, right? The tools that I use at the end, their main job is the filtering and the visualization. The upfront part, where I actually capture it off the wire, there's really not that good of a way to filter out that stuff. Either you're going to be using like, Bro, most likely, or you're going to be doing full PCAP analysis. And so the filtering process as well towards the end, depending on what tool you're using, if you're still in the process of learning it, it's a lot of trial and error. You got to figure out how that tool works to filter out that data that you may or may not care about in the first place. And then you're still researching what is normal, which isn't ever going to go away. And then you want to be able to easily generate custom alerts and reports automatically. If a tool doesn't allow you to do that, but it does a lot of other things well, why couldn't I have generated that alert much earlier in the process and still fed it into my tool later to visualize? So pushing this part of the process much earlier is going to be what the focus of my demo project is on, which I'll get to, which is Gourmet. So if you swung by my booth today, you've seen a little handout that I got about Gourmet. So the idea behind Gourmet is let's take the filtering and analysis process and push that as early as we can in the pipeline, right? With Bro, you have Bro scripting, and that's pretty commonplace to use that. But can we make it so that as a community, when I want to customize how I secure my environment, can I push those customizations as early in the process and distribute those customizations as widely as possible? And so I know it's ironic. I'm telling you all these tools will not solve your problems, and now I'm demoing a tool. I get it. But it's not so much about the tool, it's more of the approach to network security. The idea that if we can push the filtering analysis process as early as we can, we won't end up with a big data problem towards the end of the process. And so demo time. Let's see if this will open. All right, so let's say we take that example that I gave. Oh, this won't go. Take the example that I gave about the Netflix, detecting Netflix. Let's blow that up a little bit. Does that work for everybody? Right about there? Yeah, cool. Let's take the example I gave about detecting Netflix after bedtime. If you wanted to do that, what would happen is you probably feed all of your DNS data into Elasticsearch. Then on the Kibana side of things, you would just check to see if from a certain range of IP addresses at a certain time in the night, was there a DNS query that contained netflix.com? If so, however you want it to alert you. Do you want it to send you a message on Slack? Do you want it to pop up this big red box that says your child's still up? Like whatever you want to do. But if we can push that as early on in the process, for this simple type of problem, obviously more complex types of problems, you're going to need these tools later on. But for this simple type of, simple example, why can't we just do this at the sensor level? Why can't, as packets come into the sensor that we're taking directly off the wire, if we see a DNS packet that has, Netflix.com in it after a certain time from a certain range of IP addresses, have it send a message on Slackbot to us directly. And so if we build, let's see. Let's get rid of all that. All right, so main's already built, I think. So with Go, this will be a little bit about how Go works for those not familiar as well. I've built a Go binary, just doing Go build. Let's call it Gourmet instead. And so if we run Gourmet by default, what this is doing is I've specified in default values.yaml my configuration. And in the configuration file, what it's going to have is analyzers. And those analyzers are going to take your standard connection traffic, enrich it, do something with it, and then spit out a log file. I don't have permission because I need to run this command, setcap. If anybody's familiar with this, it allows you to capture packets without sudo. But first you have to run it with sudo. So we'll do that. All right, so now it's running. Open up a new tab. That's awful. All right, so gourmet.log has been, it's logs getting appended to it. Or maybe not. Oh, I know why. So this is all in a container right now, so I need to actually make some web requests. So we'll do that. All right, so let's just go to Google. Run those couple things. And now if we go back, yeah, gourmet.log's a little bigger. And so this is what Gourmet spit out. All the connection traffic, so your standard con logs, you'll see the same information that you would always see there. But then you see this field called analyzers. And as you add analyzers to Gourmet, you will be able to basically add key value pairs where the key is some string, the value is literally whatever you want it to be. And it'll start adding that to your connection. So if you're familiar with Bro, the idea of having a bunch of CSVs that are linked by a connection UID, bring all those together, put all of those things mapped to the connection UID into one JSON object, and then spit that out to a single log file. And so for things on DNS port 53, we haven't loaded the DNS Analyzer, so it's just giving us standard com log information. But if we go down to, keep going. There we go, HTTP. We'll see that for the request I made to either Google or WebScan test, the HTTP Analyzer was loaded. And so now you get all this information about your HTTP requests as JSON. And this is all using Go's open source libraries. This isn't anything like crazy. There's no magic or secret sauce. It's just the way that Go does HTTP, the same way that Python has all their HTTP libraries. Let's just give the bytes from the packet, tear out the HTTP data, and put that in a JSON object. So nothing crazy. But where this can get fun is if and this is the config file, is if I add this analyzer I wrote called the bedtime analyzer. And the bedtime analyzer depends on the DNS Analyzer. Now, I haven't loaded the DNS Analyzer. That's on purpose. We're going to let it break for a second. And let's see. All right. Need to grab my Slack token. I totally forgot to add that to this config. I was going to have this config preloaded, but I did not add the Slack token like I wanted. So you're going to see me get to go to my Slack and grab this real quick. I'll have to rotate these after. That's fine. It'll all be good. I can do this off screen actually. Is there an outlet? Oh, cool. Does that fit? All right, well, let's just pray that my laptop with 18 minutes left, we can get this done in, well, yeah, about 18 minutes. All right, so okay, this will tip. That'll fit. All right, so this config file, if we just go through it real quick, you get to define your interface, what type of packet capture technology you want to use. So if you want AF packet, you just make this AF packet. Promiscuous mode, snapshot length, the standard stuff that any packet capture you're going to be wanting to configure this stuff. And then when I start adding in analyzers, what this allows me to do is I can, and I'll pull up the code. Workflow's all thrown off right now. If we look at what an analyzer is, who knows where to go for Zoom and VS Code? So edit, maybe? All right. Well, if you I apologize. To create your own analyzer in Go, all you have to do is implement these two functions, filter and analyze. Filter, all it does is take in a connection object. Connection object is either going to be a UDP packet turned into a conn log, just for the bro analogy's sake, and then, or a TCP stream that's been reassembled and made into a connection object. It's just going to maintain or have your basic connection metadata. And then also it has your payload. The payload isn't logged by default, but when you write your analyze function, that's your ability to actually take the connection apart, going on underneath the hood. Result, like I said, can be literally anything you want, as long as you define a key function so that it can be logged. And so what this allows you to do is, as early on in the process as possible, I'm going to be getting all of my UDP packets and TCP streams that have been reassembled, and do I want to keep them? Do I not want to keep them? If my filter returns false, then I'm just going to throw it in the trash, and I don't care about that connection. If it's true, then I'm going to keep it, and I'm going to analyze it. And so I don't know if my demo is going to work, honestly, because I have to do all the setup. But with the bedtime analyzer, what I wrote, which is on GitHub if you want to look at it, is, okay, all I care about is DNS requests that occur in a certain range of IP addresses after 9 p.m. at night. Let's say that's bedtime, before 6 a.m. So that's my filter function, right? That's the only things I really care about for this, this specific situation. Then for analyze, you actually check and see, okay, is netflix.com in the domain? If so, call the Slackbot function that I wrote. And since this is all code, I can just write the Slackbot function in the analyzer itself, because the way that these analyzers work is it's another Go repository, which is either hosted on GitHub, GitLab, somewhere, that I then specify YAML, gets pulled down automatically, built as a plugin. That plugin then gets put inside of Gourmet, and now you can have all of these various different things enriching your core sensor without having to wait until 3 or 4 steps down the process to start doing all that enrichment. And so you're saving a lot of bandwidth and a lot of storage doing something like that using Gourmet. And so thinking about it this way from a home defense perspective, I don't have the storage capacity to store a full PCAP of my network for weeks, months at a time. I don't have the bandwidth to be able to send all that stuff if I have just a standard commodity router. Thanks.
Limited range on that.
A little bit. There we go. Cool. So from a home defense, like I was saying, from a home defense perspective, it makes sense to push this as early on in the process because I don't want to have to store all this stuff and do all this complex Elasticsearch setup and Kibana setup if I can get rid of 95% of the data up front because I don't care about it? Gourmet was designed to do it like this because there's a lot of problems with just sending full PCAP all the way down the pipe and then waiting towards the end to actually do all the analysis. So not saying this is the best way to do it or this is the right way to do it, but I think creating a very simple way for you as the home defender or whoever to implement your own customizations of your network defense as early on in the process as possible. It's just, from what I've seen, from the work I've been doing, it just saves you a lot of hassle and struggle down the road. So back. This guy. Just wrapping up real quick. That went shorter because the demo's not going to work for me right now. As a home defender, there's a lot of data going on, and as IoT continues to, get into your home, sending a lot more data across the wire, filtering out as much unnecessary data as early as possible is going to save you a lot of storage and bandwidth. You shouldn't take the approach of turn on all the things and hope that the bad guy magically pops out, or turn on all the things and hope that you'll have a greater understanding of your network, because you're just going to be overwhelmed with how much is going on with all these different tools. And so the tools are great. Like, the tools do an amazing job, but you shouldn't be dependent upon what they're spitting out. You should have more control as early on in the process as possible with what data you're looking at. And so kind of the closing thesis of this talk is, as more and more IoT comes into your home, start thinking about, okay, what specific decisions do I make on a daily basis with my data? What services or applications or devices in my network should I care about based on the level of risk that they introduce into my network? And how can I have greater control over the data that is being sent across my network through the tools that I use, and not having it be the opposite, where based on the tools that I use, here's what I'm able to do. Kind of flipping that equation is kind of the focus of this talk, and I think is the best approach to home defense. And so I know this ended a lot earlier than it should have, but good for any questions. First question gets this guy, so fire away. What's going on? Yeah, this is all going to be published. No. Cool. Anyone else? Yep, right there. Yep, so the question was, once Gourmet processes your network traffic and spits out, JSON, how does that then get presented to the user in a more, a GUI or something else? Is that generally what the question was? So the idea, like I said, the tools that exist for visualization are great already. Kibana, Splunk, or not Splunk, Kibana, it's the main one, I guess, coming to my mind right now. This isn't trying to replace any of those things. The idea is, how can I, as early on in the process, gain greater control of the data that I send to tools? Because just a lot of data that you don't need. And then on the flip side, with Bro and a lot of the other tools that take your for you, you're like, is the main goal of the project, not necessarily replacing Kibana, because there's already a lot of good work there. All right. The idea is either get Gourmet to the point where it is the source that you use, and then the other ones, you can do full PCAP just for posterity, but the goal is have a sensor that's is the ability to be customized to your liking, so that once it gets to that point where you've mapped out, your risk assessment, your threats, however you define the best way they're the types of data that you care about, and you've mapped that into Gourmet analyzers to pick apart the various pieces of data easily and create, spit all that out, then that is then the sensor that you use for analyzing the data later on in Splunk and Kibana and everything else. Yep.
So assume that I am a normal adult who tries to run a web management network, but doesn't have time to go to all the tools to do that or something. Hey, you're a very good AV provider, from 9 o'clock router and your Wi-Fi router. Fish out all the stuff.
Mm-hmm. Yeah, I mean, so you have to ask whose network was it designed for, right? If there's some machine learning algorithm that's been trained and modeled off of some network, whose network was that? What data were they using? Why is that the solution for me? And so in many situations, it's going to give you a lot more information than you already had if you didn't have anything to start with. But the best course of action is early on in the process, have as much information to start with. And so as the data moves from your sensor to your indexing with Elasticsearch to then being visualized in Kibana, in that process, as early as possible, I would like to gain as much control and granularity on what's being fed where so that I don't have to do all that legwork later on. Right. So the reason that and I wanted to get into this more in the demo, but I didn't have a chance. So with Gourmet, you implement 2 functions to write your own analyzer. And then once you do that, it gets put up on GitHub. So the people that do write code, that do want to make Gourmet or whatever product better, having it so that the way that Go, the language works, is I can just specify a GitHub URL, and that's my package. And so part of what Gourmet is building right now is having that sort of package manager, so that if I want to deploy this technology to defend my home network, if I care about these, and these things, I should be able to just go into a GUI, click on I want these 4 analyzers added to my sensor, pulls them down, runs it. Right now, that's what we're working on. The analyzers work. It's just you have to do it with the YAML file right now. But the ultimate goal is, be able to, as a normal user who doesn't know how to program, if I do know that I have these certain devices on my network, and these analyzers have been written for these certain devices, or I care about these certain things, these analyzers take connections, look to see if those things exist, and then spits out results. If I can select those from a GUI and just package them all up into one sensor, spit that out, that's one of the big design goals right now with Gourmet. Right. Yep. So. Right, so, I mean, that's like the universal question, right? Is if I've already been owned, how do I defend myself? If I'm trying to define normal, because I have no definition of normal, I would like to think that if you put any sort of network sensor, whether it's just Wireshark or whatever, on your network without specifying what you care about to begin with, you're not even going to find that bad guy because there's so much noise around it. Getting rid of the noise at the start is how you start getting more into selectively targeting which devices might have a bad guy, analyzing, so like the IoT speaker, right, that I mentioned in the example. Probably want to know when that's talking to the internet And if that's talking to the internet when there's nobody home, why is it talking to the internet? And just trying to start building out those sort of questions and answers for just creating greater understanding of what's going on. Because as a community, like there's a lot of shit out there that we don't know about. We don't really know how it works from like an IoT perspective because it's hard. It's hard to actually look at all that stuff. And so if there's an easy way to do the research, find out how it works, define an analyzer that says, okay, this is normal, this is not normal, publish that, then someone else who doesn't have the time or technical wherewithal to do all that research, they can just take that and be, okay, supposedly this makes sure that this device is talking normally. We just plug that in, and just creating that sort of back and forth collective security approach is kind of what Gourmet is looking to do with the analyzers. But yeah, but to your question though, like if you're already owned, how do you like find the thing? No, so I mean you can say all IPs. For all IPs, capture DNS, and so then your filter function would literally just be return IP.source equals 53 or IP.destination equals 53 for the ports. That would be your filter function. And so now you're analyzing all DNS, and then your analyze function is going to actually go into the bytes and make sure that like and the library that this is using is GoPacket, which is very similar to Scapy. And so a lot of the work's already been done to take raw bytes, turn that into layers of your network. So like they already have like a DNS layer, a HTTP or TCP layer. HTTP is a library. So like just taking all those open source libraries and putting them together, because it is like a standard programming language, you get a lot of power and flexibility in building out analyzers that way early on in the process. So. Yep. Absolutely, yeah. So that's really the same space. They occupy the same space. With Gourmet, the idea is let me make it as simple as possible to customize. Let me streamline the configuration process, and then just spit out one JSON file that has all your comm logs that have already been enriched, and depending on which protocol it is, have all that data. Because with Bro right now, it's like I have 10 different CSVs. I got a connection UID. I link all them together, depending on where the connection ID shows up, and then that becomes my like, here's what your connection is doing. It'd be nice if you just had one JSON file that spits out, all that stuff in one JSON object. So some design decisions like that, just streamlining that process, they do occupy the same space once there is enough protocol analyzers and once, because the interface to create, so with bro scripting, right? Bro scripts, you have a bunch of events, you write a way to handle that event, and then you can either add that to a log or create an alert or use the logging framework. Being able to just append it to your JSON object, I mean, that's right now what it does. Adding the alert framework and all that other stuff is stuff that we're working on as well. So that is ultimately the goal, though, is to occupy that same space. All right. Gave you all 15 minutes, so no more questions. That's all I got. Thanks for coming.